The hindwheel wind tunnel is a fantastic tool. It's state-of-the-art in Formula One, and even in road car development there is nothing comparable so far. We can go up to 300 kph. We can measure 60% scale cars. We can measure the real race car. We can put two model cars after each other into the tunnel. We can simulate cornering while turning the car. So everything is possible, and this gives us a very powerful tool to develop the shape of the car. The hindwheel wind tunnel is a fantastic tool, but it is just a tool. The real target is to improve the aerodynamics of the car. And in order to do that, we work in two areas. One is the experimental work in the wind tunnel, and on the other hand, we have the most powerful supercomputer in Europe in order to simulate the airflow over the car. It is called computational fluid dynamics. And by having those two tools, they spur each other, and we are able to develop the shape of the car much quicker and much better.
In the wind tunnel, on a 60% model, we speak also about the experimental aerodynamic. We use different parts, basically we bolt the parts on a car, and then we run this model in the wind tunnel. We run in different speeds, and we also run in different car conditions. We are simulating conditions like we see them on a track. We run straight ahead, but also cornering, side wind, and also with locked front wheels. The big advantage of CFD is that we can investigate on components which don't really exist. Basically, we don't need a physical part. We are just base all the simulations on computer data. We can run different versions of a rear wing, for example. We can optimize the shape of a wing and then make already a pre-selection of what is going to be into the wind tunnel itself. The big advantage of the experimental work in the wind tunnel is that we always have the complete car. That means with the data we have available after these test runs, we know exactly how the overall aerodynamic will behave. That means how the car will behave then on a racetrack. A perfect aerodynamic car is a car with a high aerodynamic efficiency. That means high downforce value for low drag. But this alone is not deciding if it's a perfect car. It's also very important that under all driving conditions, cornering, straight ahead, with steering lock, the aerodynamic is stable. That means the car itself is stable and produces a high amount of downforce.